Now, let us revisit the economic order quantity model. First of all, that would be the foundation for our different advanced models and techniques, which we will cover in the coming sessions. So you should refresh yourself about the economic order quantity EOQ model. What were the assumptions, the basic assumptions of economic order quantity? The demand and the lead time are known with certainty. That means you know what is the exact lead time, you know what is the demand. That's true for make to forecast products, especially the perfect EDLP products. All costs are linear and known. You know what are the costs involved in your supply chain, and you also know that they are linear in nature. Linear in nature means if the cost of first 10 items is $100, let's say the carrying cost is $100, the cost of next 10 items would also be $100. It would not be decreasing. So it should be linear in nature. No stockouts are allowed. That means if you don't have inventory with you, that means your inventory is at the zero level. Then there is no order as well. There is no customer order. That might be a bit ideal or strong assumption, but that is the basic assumption of EOQ model. We can relax it in different models. You would have done it in your different courses, but I'm just revisiting the basic EOQ model. Now, for my example, I'm taking different notations. Let's define A being the ordering cost or the setup cost. You can define it as, in your previous courses, you might have defined it with S. I'm here defining it as A. It doesn't matter because you can define it. If S is feasible for you, you can use S. C is the unit purchase cost. It's one of the universal nomenclature. D is the annual demand. L is the lead time in days. Q is the order quantity. I is the interest rate per year. For carrying cost, I might require the interest rate, so I have taken it as I. R is the reorder point. At what level you need to reorder. S is the small s is the safety stock. T is the transit time in days. Big T is the unit transportation cost. Small t would be used for the transit time and big T would be used for the unit transportation cost. S is the storage cost per unit, and H, small h, is the holding cost per unit and is given by I, C plus T. That means holding cost would be interest rate per year multiplied by C is defined as the unit purchase cost, and big T is the transportation cost. And C total is the total annual cost. So we can specify the model as follows. The total cost would be the ordering cost plus the purchase cost plus inventory carrying cost plus transportation cost plus in-transit inventory cost. I know that the basic inventory model which you have discussed before would only have the ordering cost, the purchase cost plus inventory cost. These three costs. But even at the basic level, we can add the transportation cost and in-transit inventory cost in it. It doesn't matter. It will not affect the assumptions, basic assumptions of EOQ. That is why I have added it into the basic model as well. So annual ordering cost will be equal to the cost per order multiplied by number of orders per year. So that would be A, D over Q. You would have defined it in the form of D over QS as well if you are using S instead of A as a notation. So D over Q would be your total setups during the year. Demand divided by the quantity which you are producing. So if it is 5, that means there would be 5 orders or 5 setups. If you are a manufacturer, you will call it a setup cost. If you are a retailer, you will call it the ordering cost. here I'm using the nomenclature for the retailer. So I used annual ordering cost. Then we have annual purchase cost, which would be the cost per unit multiplied by the demand per year. That means it would be the simple CD. Whatever is the demand, just multiply it with the unit cost per unit at the price, the cost at which you will buy it. Then annual holding cost. Annual holding cost would be the average inventory multiplied by the storage cost per unit plus cost per unit plus transportation cost per unit multiplied by interest rate. I have expanded it. You would have gone through the holding cost like having like half of the inventory QH, or if it is not big H, HC. I have expanded it in order to just tell you some detail about this HC, that how would you actually calculate it. So Q over 2 would be the same like you know before, 1 over 2 Q. So that is Q over 2. Then you should have, we have used S as a symbol for a storage cost per unit. Then plus the cost per unit C plus the transportation cost into I. That will actually give you the total holding cost, including your transportation cost. If transportation cost is not there, let's say your supply chain is not regional, it is just based in a city. So in a city, you do not have a significant transportation cost. It just goes from it just travels like 3 kilometers or 4 kilometers, and you think that that transportation cost is not that significant to be included in then just T would be going. Otherwise, all the T would not be here, and all the expression would remain the same. So Q over 2H is when S is significant compared with C plus TI. It will just become H if your storage cost is not that significant. It is possible that for some businesses, S is not, the storage cost per unit is not that significant. I have my own warehouse, and let's say my product doesn't require any special material handling, and it can just stay there for a longer period of time, and it doesn't get damaged there as well, and it doesn't require any security, or it is in my manufacturing premises. And if it is located in my manufacturing premises, the same security that is for my whole manufacturing unit would be for that warehouse. In that case, my storage cost could be insignificant. In that case, the expression would just be Q over 2H. Otherwise, it would be the detailed expression is this one, if you have a significant storage cost as well. Then a simple transportation cost would be the transportation cost per unit multiplied by the annual demand. So T into D, that would be my total transportation cost if it is significant. If it is not significant, I will not include it in my expression. But most of the time, supply chains or in a logistical activity, transportation is actually something which is very important in nature. That is why it has been included in it. In transit inventory cost, that was the last cost which I have included in the cost function, would be the interest rate per year, that is the I, multiplied by the unit purchase price into the annual demand D multiplied by the transit time in years. So what would that be? I CD into small t divided by 365. It is divided by 365 in order to have same unit for all of them. It would be from per year to per day. You can actually convert it. So what would be my total cost function then? That would be my C total would be, in terms of Q, would be my ordering cost plus my purchase cost plus my holding cost, total holding cost, plus my transportation cost, plus my in-transit inventory cost. So what we need to do, that we have to take what you have done in order to find the best Q from here, I need to take the first derivative. Then after that, I have to check the second derivative. If it is greater than 0, then the function would be minimized. Had it been a maximizing function, it would be less than 0. So after that, you solve the first derivative by equating it equal to 0 and then solve it for Q. When you solve it for Q, this would be your final impression. The final expression for Q, 1 over 2 means the under root. It would be similar to what you have discussed before, and Q would be just 2AD over H if your S is very small. That would be with the under root. So now we know this was actually the economic order quantity. So if you include the transportation cost and the in-transit inventory, by the way, actually didn't affect my EOQ. Then the reorder point for this situation is simply equal to the lead time, demand plus safety. What is that? My reorder point is just the safety stock plus the lead time divided by 365. So it would be in days now. My lead time would be in days because my demand is for the year. So I need to convert it into days. To my reorder time, reorder point would be LD, lead time, into the demand divided by 365 plus S. Students, you may know from your previous courses that how would you calculate, or what are the different techniques of calculating the safety stock. This would not be in the scope of this course, and the overall reorder point. I hope you can actually refresh that as well. But that reorder point here would just simply be your safety stock, which you have calculated, plus the lead time in days. Thank you.